We need large amounts of water every single day, for example when drinking or watering our gardens. It's often difficult to estimate how much we consume, so we use water meters in many areas of everyday life to accurately measure our consumption. Water meters allow us to record and pay for our requirements accurately. We rely on these devices. And municipal water works that provide enormous amounts of water around the clock rely on such equipment just as much. Waterworks often obtain such large amounts of water from national or cross-regional organizations. These organizations produce or extract the water, treat it, and transport this valuable commodity via pipelines to cities and communities. Unlike the water meters used in households, the devices they use have to measure flow based on industrial measurement methods. Endress and Hauser is one of the world's leading manufacturers of such high-end flow meters, which for decades have been serving a wide variety of industries with great success. In numerous areas of daily life, products are traded, sold, and billed in liquid form. Water, milk, and dyes, as well as fuels for industry and transportation. Such trade typically involves very large amounts of money. At the service station, we trust the flow meters in the pumps to record the correct amount of fuel dispensed into our tanks. Whether or not we pay for the exact amount purchased depends on flow meter accuracy. For very small quantities, measurement inaccuracies may not cause losses significant enough for concern. But for oil tankers with huge capacities, the story is very different. When filling these tankers, even the tiniest measurement uncertainty can result in enormous shortfalls in end-of-year accounting, sometimes for the consumer and sometimes for the supplier. Therefore, all commercial measuring devices must meet certain legal requirements. But how can we know how accurate a flow meter really is? A calibration is the only way to answer this question definitively. For this purpose, Endress and Hauser operates highly accurate calibration facilities throughout the world. The accuracy of flow meters is of decisive importance, both in business transactions and for industrial applications. For this reason, Endress and Hauser has been building state-of-the-art calibration facilities for a long time to prove the accuracy of its own instruments flawlessly and traceably. These facilities apply highly precise measuring methods favoring calibration based on the gravimetric method. During calibration, it is determined to which extent a value displayed on a flow meter deviates or not from a defined reference. To do so, the device under test is installed in the measurement section of the calibration rig and then connected electrically to the control system. The device and the reference itself, a high-precision calibration scale, are connected to each other by a system of piping that forms a circuit. A pump ensures a uniform flow of water through the pipeline, and a supply tank ensures that enough water is available for the calibration measurement. The calibration process begins as water is fed through the system and adjusted to the desired flow rate. Once the correct rate of flow has been established, the calibration measurement can begin. The water stream is then diverted at high speed into the weighing container, while at the same time, the plant control system activates the electronic flow counter of the device under test. At the end of a previously defined time period, the calibration measurement is terminated and the flow of water into the weighing container stopped. The last step of the calibration process is to calculate the reference mass flow based on the data collected, the measured time and mass. This reference value, determined with the scale, is compared to the value measured by the device under test to determine its deviation. This comparison makes it possible to correct tiny discrepancies by adjusting the device. In practice, besides the gravimetric measurement method, a volumetric calibration method is also applied. Instead of a weighing scale, the volumetric method uses a measuring container. The quantity of water collected in it is measured by a precision volume gauge. As the leader in calibration metrology, Endress and Hauser defines the highest standards of quality and precision. Every calibration system we build is designed and operated according to stringent, internationally recognized criteria. No other flow meter manufacturer maintains as many calibration facilities worldwide as Endress and Hauser. But how can we, as a global company, prove that our calibration rigs reproduce the flow variable correctly and thus meet the high standards that are required of a reference? The answer is traceability. This means that all testing equipment, for example for weight, pressure, temperature, and time, and therefore the calibration rig itself, can be traced to the national reference standards of a country. This traceability is ensured by an uninterrupted chain of calibrations. The most important test equipment for gravimetric calibration rigs are a scale and its weighing container. These, together with a time measurement, are used to determine the reference flow rate. Because calibration scales are typically in operation around the clock, they are checked regularly using calibrated reference weights, and if necessary, their outputs are corrected. This is done by hanging the reference weights on the weighing container. The reference weights themselves have to be inspected periodically by a legally recognized metrology institute. In Switzerland, that's the Federal Institute of Metrology, known as METAS. To do this, the calibration weights are transported to METAS in Bern, where they're compared to the national reference weights kept there. These comparison measurements are carried out using a high-precision scale known as a mass comparator. The national reference weights, in turn, are compared to a copy of the world's supreme mass reference, the International Prototype Kilogram. This makes it possible to determine and correct calibration errors that might arise. Since 1889, the International Prototype Kilogram has been kept at the International Office of Weights and Measures in Sèvres, a suburb of Paris. Around the world, the International Prototype Kilogram serves as the basic unit for mass in the international system of units. When calibrating measuring devices, correct traceability back to the International Prototype Kilogram is decisive. However, an equally decisive factor is the trustworthiness of a calibration rig and its operator. Only independent accreditation bodies can verify and provide reliable proof of this trustworthiness. Year after year, Endress and Hauser has been calibrating hundreds of thousands of measurement devices. Therefore, every one of our flow calibration rigs has been accredited by official agencies according to ISO IEC 17025. The fact that this is unique worldwide leads to the high degree of confidence in our metrology. During an accreditation process, various criteria are evaluated according to the most stringent quality standards, such as the traceability of test equipment, training of operating personnel, technical infrastructure, and quality management in accordance with ISO 9001. Most countries have their own accreditation bodies. Founded in the 1980s, the global association of these institutions, called ILAC, ensures that every accreditation is carried out according to identical standards worldwide. The member states of ILAC are organized into regional associations, for example in North and South America. in the Asia-Pacific region, in Africa and the Near East, and in Europe. The European cooperation consists of numerous full members, including accreditation bodies in France, Germany, and in Switzerland. For years, the Swiss Accreditation Service, or SAS, has been certifying Endres and Hauser flow calibration rigs in Rheinach and carrying out annual audits. The stamps on our calibration certificates from ILAC MRA and SAS show that Endres and Hauser is accredited as a calibration center for flow. True to the motto, once accredited, always accepted. Additional accreditation for Endres and Hauser include from the American Association for Laboratory Accreditation and from the China National Accreditation Service. Accredited systems are recognized all over the world and inspected regularly by national supervisory bodies. Only accredited calibration facilities are 100% trustworthy, and only traceability guarantees correct measurement results. Our calibration facilities are available to you around the clock all over the world. Endres and Hauser, you can depend on us.